and lives of more opportunity and choice. I think that's one of the other things that's sort of underappreciated. Your choice of job, a couple hundred years ago, literally half the workforce had to be farmers just to feed the
Mhm.
entire population, and most of the rest of the workforce was making basic necessities like clothing. Um, and today there's just like a vast, array of jobs to choose from. Um, your choice of who to marry and when to marry, or whether to get married at all, your choice of whether to have children and when to have them and how many to have, your choice of where to live, all of these like basic things that make up a life, an individual life. So many of these choices were just not open to people in the past, or the choices were extremely restricted.
Yeah, so I mean, why don't you tell everybody, who you are and give us a little bit of your background and history, and then we'll talk plenty about what you're working on now.
Yeah, sure. So, hey, my name is Jason Crawford, and I run a blog which has now become a nonprofit organization called The Roots of Progress, all about the history of technology and the philosophy of progress. And yeah, I used to be in tech myself, so I spent almost 20 years in the sort of Silicon Valley tech world. My background's in computer science. I was a software engineer, an engineering manager, and a tech startup founder. Co-founded a couple of tech startups, and then started working on this blog as like a side project. It was a hobby, and got totally obsessed with it, and ended up deciding that there was nothing I'd rather do more than work on the blog full time. So now here I am.
That's really cool. I remember, I think when we first met, I believe I was trying to recruit you, as I am always trying to recruit people to come work at Lambda School, and
Yes,
you were kind
you
of
very
like,
nearly did. You were good.
and this was a twinkle in your eye, right? I think you'd had the idea and you were interested in it, but there was not like, there wasn't a there's not a super clear path for making that a full time thing,
No.
and you're just like, there was just something like eating at you that it felt like you had to get out. What was that? How would you describe why you felt? And I remember when I met you, I was like, I absolutely want you to work at Lambda School, but man, when you talk about what is now Roots of Progress, I don't even know if it was called that then. There's just like, the passion is so clear. Like, I may have said, which is something a founder should never do. Like, maybe you should go do that instead. Obviously, would prefer for you to come work for us. But what is it that got you so fired up?
Yeah. So like for context, at that time it was just a blog, and it was a blog I'd been doing in my spare time, totally as a hobby. It was The Roots of Progress, like that was the name I chose for it in the beginning of 2017. And I'd been writing it for a while. At first, I literally didn't care who read it. I figured it would just be a few of my friends, and that was cool. I set it up with a Twitter account and a mailing list, and some basic trappings of like, this is a blog that you can follow. But I was also, I said, look, I'm not gonna stress over like promoting this or anything. But then one day, one of my posts just sort of took off and went viral. It hit number one on Hacker News. It got retweeted a bunch, and this was the post about the history of the bicycle, and
Mm.
why was the bicycle not invented until like the late 1800s, when on the face of it, you might not obviously see any reason why we couldn't have had bicycles in like the Roman Empire or something. And this was originally just something I just posed this question on Twitter, and like a bunch of people responded, and it got so interesting that I decided to write it up, like do my like to actually go research it and write it up as a
What
blog.
what what even gave you that question? How did that? You know,
Yeah,
were you
so
riding a
I was
bicycle and
just
like
okay.
why?
So the impetus for this whole thing was I really wanted to understand the story of human progress. It started out as maybe I just want to understand the Industrial Revolution, but then I sort of very quickly broadened it to like, no, this is about the story of human progress. How did I get obsessed with that? Well, um, a big part of it is just noticing how much this sort of thing underlies people's views about the world, their views about society and politics. I realized at one point that like when people are talking about political issues, often they can't agree on solutions because they don't even agree on what the problems are. So,
Mhm.
like, on one side, you might have someone who thinks that like global warming is the most important issue, climate change, and like that is the thing that's going to kill us all if we don't put all our energy and resources on it. And then on the other side, you might have somebody who comes in and says like, no, that climate change stuff is totally overhyped. But what you're not paying attention to is like the national debt. It's the 20, $30 trillion in national debt. That's the ticking time bomb that nobody is going to, right? And then like a third person might walk into the room and be like, no, both of you are wrong. It's racial injustice and, is the thing that is eating away at our society. And so like, they're never going to agree on what we should do as a society at any sort of political level, because they don't, each one actually dismisses the problems of the other ones, let alone the solutions. So I started thinking about, well, what problems do I care about and what kind of informs my worldview? And I realized that like a basic fact of history that informs my worldview that I think is super important is just the fact of human progress, is the fact that our living standards, the way we live, is just completely transformed over the last couple of hundred years. And life used to be pretty crappy, frankly, and none of us really want to go back and live in that world. But it was like that for thousands of years, tens of thousands of years. And then, suddenly kind of in the last couple hundred years, things got a whole lot better. And like that is possibly the most amazing fact in all of human history. And I think it deeply affects my worldview, because when I think about what kind of society I want to live in, like the first thing I think about is, well, what kind of society makes that possible? And how do we
What made
keep
that
that
happen?
going?
Let's do more of that.
Yeah, let's
Yeah.
do more of that, right? Like we should be like, I mean, I think if you care about human life and well-being and happiness and sort of people flourishing and thriving, then you should really, you should look at history and be like, yeah, wow, how did we get all those vaccines in the last 120 years? And how did we get antibiotics and clean water? And how did we get like abundant food and end famine in most parts of the world? And how is it that everybody now sleeps on like a spring mattress or a foam mattress instead of literally a bed of straw that you would like get fresh straw for your bed every night, and then in the morning like take the straw from the bed and put it into the fireplace because that's what you were burning for fuel. And that was in
Hmm.
good times, by the way, and in bad times you'd be like pulling down straw from the roof to like make your bedding or whatever. The world has been completely transformed.
So if you're going to convert me to your worldview, kind of the first thing to understand is that it's not as if, and you see this sometimes floating around like, oh, 250 years ago, everything was so idyllic and everybody lived in nature. And like, so first and foremost, it sounds like as a wholesale rejection of that notion and actually a relatively deep understanding of what life used to be like, first of all. And then you talk about, I mean, fast forward to today, and certainly there are no shortage of problems today, but you would argue far, far better than it was. I mean, certainly 1,000 years ago, certainly 200 years ago. Um, but you talk about that thing, right? If you look at, and there are different ways to measure it. Maybe GDP is the right measure, maybe it's the wrong measure, but it looks like the startupiest up and to the right graph ever. If you're looking at GDP over the long run, what is that thing? How is that? Just, do you call that progress, or is there a more finite way to look at that?
Hmm. Yeah, I mean, so progress, I think there are different types of progress. I think in the very broadest sense of progress, you want to define it sort of in humanistic terms. Progress
Hmm.
is whatever allows people to have better lives, longer, happier, healthier, lives, and lives of more opportunity and choice. I think that's one of the other things that's sort of underappreciated. Your choice of job, a couple hundred years ago, literally half the workforce had to be farmers just to feed the
Hmm.
entire population. And most of the rest of the workforce was making basic necessities like clothing. Um, and today there's just like a vast, array of jobs to choose from. Um, your choice of who to marry and when to marry, or whether to get married at all, your choice of whether to have children and when to have them and how many to have, your choice of where to live, all of these like basic things that make up a life, an individual life. So many of these choices were just not open to people in the past, or the choices were extremely restricted. Um, and not to mention, even on the level of sort of our intellectual and spiritual life, you have access today. Anybody with an internet connection, which is what the majority of adults on the planet now have access to, essentially the entirety of the world's knowledge, art, philosophy, and culture, instantly, pretty much, at a glance. And so all of those things are just different ways in which our lives are better. Now, material progress in technology and industry and the economy is, I think, a key part of this overall sort of human progress, closely linked with it, but not exactly identical. And so one of the big questions that people ask, and that I think this sort of new discipline, maybe of progress studies, needs to answer, is okay, but it basically, like, is progress good? Is material progress human progress, right? Is
Mhm.
material progress actually good for human well-being? And does it lead to overall flourishing?
Well, I think there's a broad narrative today that kind of we've gone too far. Like it was good, for some people up until the Industrial Revolution or up until social media or up until recently, and now we have processed foods and we have suburban sprawl and we have whatever else. So how do you view that? How do you determine when it's good, or do you just say progress net net is better than whatever trade offs we have to make to get it? So how do you think about that?
Yeah. So I think there's a couple of things. I mean, one thing to acknowledge is that, like, progress is messy. It's not like a simple, clean, linear story where everything just got better all the time in every dimension for everyone. There were a lot of things that were better in some really important dimension and had a bad side effect. I don't know. I think about this like medicine, right? You're going to take medicine for a disease. You understand that, like, sometimes the medicine has side effects. Those side effects might be bad, but the question is not just, are the side effects bad? If you take chemotherapy for cancer, for instance, it can give you nausea, right? Like, you wouldn't just reject the chemo out of hand because you're like, well, I don't, it gives you nausea. You got to look at, well, but is that better than the alternative? The alternative might be dying.
Hmm.
And also, are there ways to mitigate those side effects, right? And so throughout the course of history, we've found new energy sources and set up factories and so forth. And one of the things that led to was pollution. Okay, well, are there ways, are there things we can do about the pollution? Turns out, actually, we've done a lot about pollution, and air quality has gotten a lot better and so forth, right? Similar thing with cities. So, in the 19th century, when people were moving more and more, leaving the countryside and moving to the cities, they were doing that for a good reason, for opportunity, for jobs, for being just around other people. There are lots of good reasons to move to cities, but the cities were getting crowded and filthy, and they had much higher rates of disease. You're actually much more likely to die from a disease that you caught in a city in the mid 19th century than if you were in the country. But eventually, we solved that too. We had the germ theory, which was developed in the late 19th century. We put down clean water infrastructure, started having better food handling processes, pasteurized our milk, vaccines, antibiotics, etc. And so now, both the city and the country have much better rates of infectious disease, much lower, and much lower mortality from disease, than anybody did in the past. So we created an opportunity with cities that caused a problem with disease, and then later we solved the disease problem as well. So progress creates lots of problems, but the solution to those problems is usually just more progress.
Hmm. That's interesting. So, I mean, if you are going to, so if you looked at a newspaper in, I don't know what time frame you're thinking, maybe that's the late 1800s, would they say, "Oh, there's a giant disease problem in cities, and our cities are fundamentally unsustainable. Maybe we need to go back to the countryside." And then somebody found a way to innovate their way out of it, right? And I don't know what time frame that is. I'm not enough of a student of history to know. But do
Yeah,
you see, if you look at, for example, global warming as an example, there is a narrative where it's all just going to get worse and worse until we all fry, and it's just a matter of how long that will take. I'm not a big investor in anything carbon related, but you could have carbon capture or mitigate with carbon credits or that kind of thing. Do you think that even that like level of problem is something that we can just innovate our way out of, or is that far too optimistic of a view and just not being unwilling to look at our human scale problems?
um Yeah, I mean, when you say we quote we can just innovate our way out of things, that sounds a little flippant, like it's not going to be a problem. It'll be easy. Don't worry about it. And I think
Sure.
that's probably a wrong view to take. Um, but if you drop the just and you say we can innovate our way out of problems, then yes, I absolutely believe that we can. Um, I wrote so I think a good historical sort of reference point for this, and I like historical reference points because you know how they turned out, so you can sort of
Hmm.
look back on them and you have all the benefit of hindsight. But one that I wrote about for the MIT Technology Review was the case of a scientist named William Crookes and his warnings about what he called the wheat problem, which was basically the world was running out of fertilizer at the end of the 1800s. Um, so the population of the world was growing, agriculture was expanding. In the United States, they were expanding onto more and more fertile farmland throughout the country, and people were using a lot more fertilizers. And one of the places they were getting this from was they had discovered sources of fertilizer, including okay, this is a little hilarious. There are these islands off the coast of Peru in South America where it almost never rained, and they had accumulated untold centuries or millennia of seagull droppings.
Hmm.
And this like seagull guano was some of the most powerful natural fertilizer known to humanity at this point. And they
So they
are
find a
literally
giant repository of seagull dung.
yeah, right. And they are literally mining this like it's a rock quarry or
Wow.
something, right? They're
They're
going in and they're
fracking
like digging
the
up seagull
seagull.
guano
Yeah.
and they're putting it on boats and they're shipping it all over the world because it's this incredibly powerful fertilizer. Anyway,
Fascinating.
they were blasting through the reserves of that very quickly and they basically used it all up within decades. And so this guy Crooks, he gives this big speech where he says, hey world, we are running out of fertilizer and we are going to run out of food if we don't solve this problem. And it's funny because on the one hand, he was sort of an alarmist, right? He's making
Hmm.
he's telling people, "Whoa, we've got this big problem. This is like a huge thing we all need to pay attention to." And he was kind of denounced as an alarmist. And there were people who wrote rebuttals of all sorts, and even this one guy who was like, "Yeah, you just ever since Thomas Malthus, we've had like so many discussions about this kind of thing." Because it turned out there was another
Yeah,
guy at the
every
time who
20
was
years, there's another one of you cranks that says we're going to run out of X and that'll be the
yeah,
end.
right.
And
It turns out at around the time there was a guy calling peak coal,
mhm.
who thought that was afraid that Britain was going to run out of coal, and that would be like the end of Britain's dominance in the world. There were other people warning about running out of precious metals like gold and silver and so forth. And so here comes this guy who says we're going to run out of fertilizer. But the other interesting thing about the way Crooks framed the problem was in the very speech where he warned about this problem, he also talked about what the solutions could be. And he was
Hmm.
basically calling to the chemists of the world to step forward and find a way to create synthetic fertilizer. And he even talked about a potential way that this could happen, using the nitrogen in the atmosphere as the basis for the fertilizer. And he kind of went into some of the details of how it could happen. So he was fairly optimistic that like a solution would be found. But he also wanted to make it really clear that if we just sat on our butts, we're facing a dire problem here.
Yeah, it's an interesting framing. And I think, you can look at the problems of today and how many of us are alarmist and offering potential solutions, right? Versus just, oh my gosh. And the thing that I've found is interesting in reading Roots of Progress is there's so many times when honestly it feels like, okay, this is it. Like we've reached the peak, we've maximized all the progress that there is to have been maximized, and like this is the thing that like we won't be able to solve in the long run. And then eventually, and sometimes in unintuitive ways, people find a way to solve it. And it feels like, at certain times today we're not quite as optimistic. Where there is, well, in some things there is all the alarmism and none of the optimism. In some things there's all the optimism and none of the alarmism. And you kind of have to have both to some extent, right? Like this gentleman Crooks was his name.
Yeah.
He wasn't wrong, right? Like you can be alarmist and right, and you could probably make an argument that given the data that the Malthusian folks had, like they were right. They just fundamental assumptions shift under your feet. And
Yeah.
if maybe Malthusian is the wrong analogy, but Um,
No, I mean that is a
there,
funny thing about Malthus that he wrote at this time where he was like what he wrote right at the time when what he wrote was true for almost all of history, and right at the time when it was about to stop being true. So it
right.
was like a very good retrospective, but then as a guide to the future, turned out to be in a certain way completely wrong. So in that article in MIT Tech Review, I sort of distinguished between two kind of wrong approaches. One is the sort of blind optimism, which I call complacency, where you're just like, nah, there's not
Mhm,
even a problem. And then the other is blind pessimism, which I call defeatism, where
mhm.
you can't even see the potential for solutions. And both of those are mistakes. And so the alternative, I just call it solutionism, right? Where we acknowledge the reality of problems, but we're also committed to doing everything we can to find solutions.
And you've written about a few of these that I find absolutely fascinating. Let's, one was it a wheat thrasher that we talked about? What was the
Yeah,
take us through that a little bit?
I wrote something about the history of the threshing machine, which seems a little obscure, but it turns out to have, I think, some really interesting sort of broader lessons about like the importance of infrastructure, especially manufacturing infrastructure. Um, okay, so really briefly, like threshing is a stage in the harvesting and processing of wheat. When you cut down wheat, you get these grains that are in these really hard. They got this really hard casing around it, and you have to get the seed, which is the part that you eat, out of the hard casing that is indigestible. Um, so historically, this was done by literally you would just pile the grain like on the floor and you would beat it with a stick. Or you would even literally like get animals to walk over it or to drag a big heavy board over it. However you did it, it was like this violent process. You have to. I mean, the word threshing and the word thrashing used to be like synonyms basically, and so like
Hmm,
think about giving somebody a thrashing, right? That's what you're doing to the wheat. Um,
got it.
so for a long time, people thought, well, okay, can we maybe have a machine do this? And they had a machine to do the next step, which was milling, right? So when you want to grind the seed into flour, there were grain mills for that since I don't know the Roman Empire, I
That's a
believe.
relatively simple problem. Just
It's a pretty simple problem.
smash it really hard versus
Yeah,
smash it
exactly.
kind
Right.
of
You just
hard.
get a huge stone and then another huge stone, and you just put the grain in between them and you turn it around, and then the grain gets ground up. And so it wasn't like a crazy idea that you could have a threshing mill as well as a grinding mill. And so people tried to create these things, but for a long time, and throughout the 1700s, there are all these sort of attempts at people doing it, and people even patent machines, and basically none of them work. And so, even though people are talking about this since even the 1600s and definitely through the 1700s, you don't really get adoption until the very end of the 1700s in like Scotland and the early 1800s in the U.S. And so I dug into, well, okay, why is it? When you read about the trials of some of these early machines, basically the machines just broke. Like they just didn't work
Hmm,
reliably at all. Sometimes it was reported that the machine would like tear itself to pieces if something just got a little bit out of whack. Part of the way these machines are working is maybe they've got like pairs of teeth or pegs or whatever that are sort of like going like right past each other to try to because what you got to do is sort of like rub the casing off of the grain, right?
sure.
So you don't want to get it so close that it smashes the grain, but you got to get it just in there so it's kind of this hard casing is sort of rubbed off of the grain. And so one thing that would happen is if the machine got just like a little bit out of alignment, well, those teeth could like run
It
into each other, and
catches
now the
and it's
machine is
over.
like damaging
Yeah.
itself. And then even if that didn't happen, the machine could damage the grain as well. So um, basically, it took like a really good engineer to even to construct one of these machines and like tune it to the right tolerances so that it could succeed. Um, and what you find, so the interesting thing that I found was like, okay, if you invented a threshing machine today, what would you do? Well, you'd set up a factory to sell it, and you'd like take orders from across the country, around the world, and you'd like ship things to people, and you'd make them in your factory and so forth. Well, that's not how stuff was even made in those days. Um, in those days, farm equipment was typically made by like the local village blacksmith or carpenter or whatever. And there just weren't like national markets for these things. So when you even look at the advertisements that these inventors put out, when somebody said, I've invented a threshing mill, he didn't say, and you can buy it from me. Write to me at this address. What he said was, I will sell you the plans, and then you can take it to your local carpenter, and like he'll make it for you. um,
Hmm.
but it just didn't work because these machines needed to be made to like really fine tolerances, or like finer than what like a random blacksmith or carpenter could do. And so it was really the sort of revolution that happened around the end of the 1700s and into the 1800s was in manufacturing technology, and especially in a new class of machines or a new class of tools called machine tools that were things like drill bits and sort of machines for grinding away and milling and otherwise shaping parts that were specifically designed to be high precision, so that any workman could, without too much trouble, make a very finely tuned part. Overall, the history of precision is like fascinating and super underrated. I think in kind of
Huh.
the history of technology, it's one of these things that's just invisible to us today and easy to overlook. Um, but so the threshing machine couldn't really take off until basically manufacturing improved. And in fact, into the 1820s and 30s, you see that some inventors are actually contracting with like an engine manufacturing company to make their threshing machine. And now they're saying, so later on, they're saying, yeah, if you want one of my machines, write to this engine manufacturing company. They have a license on my patent and they can make it for you. So it just really
Fascinating.
speaks to like the importance of manufacturing infrastructure to be able to even give us, you know, the kind of machines that now are all around us and that, we use every day. But there was a time when like it was almost impossible for these things to have a market because there just wasn't the infrastructure of like the people and the factories and the tools that could even create this kind of stuff.
Yeah, and it's also interesting, if you think about the people who were building the tools for manufacturing, they probably didn't have the end in mind, right? They weren't thinking, oh, if I build this tool, then I can then, go on and build a threshing machine. They're just like, I'm going to build a bunch of general purpose tools that operate at a different level of, what was the word you used?
Precision.
Precision. Yeah. And
Yeah.
then people are going to probably do cool stuff with that. Let's see. And
Some of
turns
the
out,
first ones were built, were built for special purpose applications. As I mean, you being in Silicon Valley, you like the killer app comes like the platform is built on the killer app, right? You don't have a
mhm,
generic platform with no applications that somehow takes off. There's a need, there's a purpose in an application. One of the first purposes for machine tools was making locks. So as you can imagine,
mm,
locks have to be made to very high precision, right? Because you want your key to turn the lock, smoothly without any jankiness. But you don't want a key that's like even slightly off. You do not want to be able to turn the lock at all. And so locks are just like inherently this high precision thing. And at the end of the 1700s, there was this guy Brahma who had invented a new, special type of lock, and he was like not going to be able to make it, like to manufacture it at any sort of affordable price until he met this other guy, Henry Maudslay, who was this sort of mechanical genius, and he's like, I can build these machines for you. And Maudslay
mm.
built a set of machines of machine tools that were basically machines specifically made to make the parts of the lock. Later, Maudslay was involved in another project to make, again, a set of machines to do a process for the British Navy of creating pulley blocks. So, pulley blocks are this like large casing that ropes go through. You need a whole lot of them to build a ship, and the Navy was building a lot of ships. And this is like, I think this is in the middle of the Napoleonic Wars, so they need like a lot of ships. And they've got over 100 people, in some factory making these blocks out of like big oak pieces and sanding them and carving them and everything by hand. Using hand tools, and they just like can't turn out enough blocks to meet demand for the Navy. And so
Hmm.
Maudslay and this other engineer Brunel come along, and they design this whole factory and this set of tools. And basically, like 10 guys can turn out all the pulley blocks that the Navy needs based on these tools. So this is some of the origin of these machine tools. It was for these specific crucial applications.
It's fascinating. And I think one of the pieces that can tend to get lost in all of this is the importance of markets and like how much market sizing affects what can be produced. So, as an example, you mentioned, the threshing machines. There may not have been enough for one person to, invest all that time and effort and energy and figure out the whole thing just for the purpose of threshing. But once you have, one guy building a general purpose tool for one thing, and you're 80% of the way there, and somebody can take that and adapt it, and then there's a threshing machine. Like, the unlikelihood of somebody going from 0 to 1 with all of those things, but being able to take other innovations and stack them on top of each other and build things that wouldn't otherwise make sense is extremely underrated. When
Yeah,
I
totally. I
I spent
mean,
a few years
just
in the Soviet Union, and you go to the former Soviet Union, and you go to factories there, and everything was single purpose built, right?
mm,
They have one, and there wasn't great information transfer. So like the coal mining in Leningrad would be totally different from the coal mining in Moscow. And everything, I mean, they're brilliant engineers, but they're reinventing the wheel in sometimes a literal sense, but again and again and again, because without that market dynamic of, hey, if I build it in this factory, I can go sell it to all the other Soviet factories, it didn't exist. So you had like this, you had a bunch of experiments of like, let's see what we build in this factory versus that factory versus that factory, but you didn't have anywhere near there's no transferability of what happened one place to another. And I think that's fascinating, in this story, because it's not a single guy who sat down and, soup to nuts built the entire thing. It's a bunch of different people building different things and stacking them on top of each other until you get to, the end utility. And manufacturing operates like that frequently. Like, that's often how manufacturing goes.
that's a fascinating story about the Soviet Union. I had not heard that, and it's particularly interesting because, like, one of the communist criticisms of capitalism was that it would be inefficient because of duplication and not enough like standardization and systemization, right? And
Hmm.
you're saying that actually maybe under the hood there was maybe less standardization.
Well, I think, yeah, I mean, so there's truth to that, right? Because you only do things once, but then, in capitalism, there is less standardization, but there's more experimentation, but in a different way. Like, and to some extent, the notion that the Soviet Union was totally standardized is cute in theory, but when it gets to practice, it's actually really hard to standardize everything all the time. And at the end of the day, you might have somebody in one factory making a different decision from somebody in another factory. And having run a school that we tried to run very centralized for a very long time, like, just the process of passing that information from different places to keep everything in lockstep is difficult. And I think the and I think about it through the company culture lens, right? You have some of the companies that have grown the most successfully from a Silicon Valley standpoint. I look at the Amazons and the Ubers of the world, and Amazon at one point had very explicitly a goal to not centralize, to not standardize, because it can be so inefficient to try to do that if we end up with 10 things that are slightly different, well, at least everybody's going instead of trying to spend all their time organizing. And that's with code, which I would argue is much easier to do than most manufacturing would be. You're just
Yeah.
you're all
This
operating off the same GitHub. But
the
yeah.
super counterintuitive thing that Bezos said at some point was like, I don't want to find out ways for our teams to communicate more. We should be finding out ways that they need to communicate less,
Yeah, if
so
people
the
are
teams can
talking
be
to each
more
other, it's a
independent of each
fail
other.
case. That's wild. I
Yes.
mean, it makes sense because, and that is a pattern I've seen in many Silicon Valley companies. That the notion of, the code does the talking, or, the product is how we communicate with each other, is very powerful.
Yeah.
But yeah, very counterintuitive and not what you would learn in most management theory classes.
Yeah. You mentioned the importance of markets. I think that's kind of the other half of the lesson of the threshing machine story, is that like before in the 1700s, it was, even if you had invented and could manufacture a threshing machine, it was really hard to create a market for it and like sell it broadly to recoup the investment that you would have put into all of
Right.
that.
Then you can sell
Um,
3 of them,
it
and
was difficult to ship anything over any kind of a long distance because there were no railroads. There were, like, you would be shipping things probably by barge and canal, and
hmm.
then if you had to get it over land, it's like going on a wagon. Um, even in the like later in the 1840s or so, when Cyrus McCormick was working on another crucial piece of agricultural machinery, which was the reaping machine. When he sent out some of his, early orders to early customers, like some of his machines arrived late, and some of them, did not arrive in time for the harvest season, and sometimes he didn't collect payment on them and stuff. And it was all because the transportation networks at that time were just terrible. Like we had not built out railroads across the country, and you just couldn't get everything was like sort of like slow and unreliable, and very dependent on the weather. Similar with
Interesting.
just sort of like with information, right? I mean, how would you advertise, or find how would you find a market for these things? The transportation and information infrastructure today has created these like highly efficient global markets, and that means that if you need whatever 10,000 or 100,000 customers for your product to make it a viable business, like it's just easier than it's ever been to find those customers wherever they are around the world, and that just means we can
Mhm.
have more products, even niche ones.
For all the flaws of Facebook and Google, I can think of 50 companies that would not exist without one or both of those, right? I
Yeah.
think I'm actually surprised that those companies don't lean into that more, because it's always just, oh, you're taking our data and, advertising, and, nobody likes advertising, but somebody likes advertising. Like, how
There's an
many,
old saying that's like, everybody hates advertising until they lose their dog or sell their car. And I
yeah,
would add, or launch their startup.
yeah, no,
And then
yeah,
you suddenly realize, wait, advertising is actually really useful.
if I were running Facebook, or if I were running PR at Facebook, which I should absolutely not do, that would be a terrible idea. But all of my focus would be on, you know, yeah, we collect your data so we can show you more targeted ads. But that's not, it's not about the user experience of that. It's about these companies that we're enabling to reach customers in a better
Yeah.
way than they ever would have been able to. Maybe that's too
To
abstract for
Facebook's
people to
credit, they've
really
actually been doing some of
cling
that.
on
I've
to.
seen them run ads that are basically like, hey, people have ideas for small businesses and they need to like reach their customers, and targeted ads like help make that happen. And it's kind of true.
Yeah, yeah, no, it's very true. I mean, imagine the level of niche product that you can get to market now versus if it was just mass media, TV and billboard. Like, it wouldn't make sense for probably, I don't know, a huge number of the percentage of products on Facebook or Google to just blanket advertise. But anyway, what's in all of your research? What has surprised you?
Yeah. Certainly been, some things I didn't expect were just some of these things that are kind of invisible and hidden. The precision thing is one of them. Precision has enabled a lot of stuff, not just machines that work better, but like one of the things precision enabled was interchangeable parts. This is sort of mind blowing, but like it used to be that even in a factory where you were assembling, say a clock, you wouldn't necessarily expect all your parts to just fit together. And so you'd pick up a
Sure.
part and it wouldn't fit, and you'd have to just like pick up a file and like file it down until it fits. And this is assembling, right? And so it turned out high precision, manufacturing enabled us to create parts that just fit together with no filing, and
Sure.
that actually sped up
Then you can
manufacturing and led to
standardize
cheaper
the
goods.
entire factory.
Yeah, totally. Um, yeah, I mean, so there's a number of things like this. When I was looking into agriculture, it turns out there's a whole story of breeding. It's amazing how many varieties of every crop there are. We talk about farming wheat or corn or rice or something, but it turns out that all of these plants have like many, many different varieties that are subtly different from each other, and everyone is adapted to like its own local climate. Every
Hmm.
plant has to be adapted to its latitude. So like how much sun do you get on different days of the year, and how much does that vary? Its own local temperature. Is the ground freezing over? How much rain does it get? What's the soil like, and so on and so forth. And so, farmers have always, I mean, throughout all of history, have been just like experimenting with different crops and trying to figure out what grows best where, and actually breeding different varieties. But this turned out to be a huge area of experimentation. And as agriculture got more scientific and as there was more kind of like deliberate research focus going into it, there was a lot of effort on breeding better and better crops. And that was just, that was something that was just basically invisible to me, right? I mean, I knew we had machines, I
Yeah.
knew we had fertilizer, but I didn't realize how much breeding mattered.
No, my father-in-law is actually a hay farmer, and they have one of the farms that they have in Northern California breeds Timothy hay, which is this very specific strain that only grows in like weird parts of Oregon because it has the right, right amount of uh, what is it, humidity and the right amount. And they have farms in Utah that grow different stuff, but the Timothy hay is like it literally trades at 10 to 100 times the price of the stuff that they grow in Utah because it's so fascinating. And it and even, I'm at the Rome research compound now, and they're trying to like breed a kind of chicken that a monk has been working on breeding since like the 60s. And it's really like it's this individual process of somebody. It takes forever, first of all, to breed things, and there's some element of random chance with genetics, but or you have to understand the probabilities. It's not a surefire shot every time. But what are some of the interesting kind of breeds that have happened? I'm sure there are a number that have just
Yeah.
we take for granted.
Well, one of the biggest breeding success stories of the 20th century actually was hybrid corn.
Hmm.
Um, so for a long time, people were trying to breed various varieties of corn. They successfully adapted corn to many different parts of the U.S. But one thing that they were not really successful at for a long period of time was getting better yields. So yield being how much corn do you get out of a given like acre, planted, right? Per seed that you plant. Um, and it's interesting. So some people. So at one point they started optimizing corn for something a little bit different, which was they started trying to optimize for protein content. And this was particularly because corn was used as feed for livestock, and so they
Hmm.
wanted to make it a better quality, better nutritious feed by having higher protein corn. So they plant a bunch of corn. They test it all for like which is the highest protein. Oh, cool! These plants have the highest protein, let's like replant those ones, right? And then they did this for a few generations. Okay, so the protein content of the corn is going up, but something else is happening, which is that the yield is going down. And so these ears of corn, they're like high in protein, the kernels are, but the ears themselves are starting to get smaller and kind of shriveled and shrunken and have fewer grains on them. And so one researcher looks at this and he's like, I think the problem is that we're inbreeding.
Hmm.
So by selecting these high protein strains, they were sort of accidentally inbreeding the corn and making this like very purebred strain. But what they found was that if you crossed these strains, if you crossed two inbred strains, you got something that was much higher yielding than the parents. And this had generally been known. It was generally sort of known that like taking two kind of like different lines and crossing them would give you a more vigorous plant. They called it vigor at the time. It's just like how much does the plant grow. So this phenomenon was called hybrid vigor, or technically
Hmm.
heterosis. And so they're looking at this and like, well, this is really interesting. The thing about corn is okay, quick primer on plants. Most plants are kind of like hermaphrodites. So plants reproduce sexually in that they have like the equivalent of like egg and sperm. It's pollen is the sperm, right? But most plants produce both, and so it's very possible for plants to fertilize themselves. And some plants like wheat do this very commonly. Corn is much more sort of promiscuous. Like the pollen just floats on the wind, and it's very easy. Like any ear of corn will sort of tend to just get pollinated by other plants. And so what this means is it's actually very difficult to maintain like a pure strain of corn without very careful selective processes. So so they start doing this, and they're like, again, they're getting more protein, but they're getting lower yields, and they're like, okay, I think we're inbreeding. They find that they can have these crosses that have higher yields, and so they're experimenting. They're like, wow, this could be a way to actually finally increase yields, like deliberately inbreed for a while to get sort of a pure line, so that we know what essentially we know what we're getting, right? We don't have like the randomness of heterozygosity, um, but then make these deliberate crosses. So what we want to do is create lots of different inbred strains, cross all of them, figure out which are the best crosses, and then like those are the ones that we can use going forwards. And so like this is a really interesting proposal to like get control over this process that previously was basically just super random, because of kind of the genetic luck of the draw. The problem was that it was so you could make seed that was very high yielding. The problem was it was an expensive process because the parents of this seed were very low yielding. So you do a bunch of work, you get a small amount of seed, but then that seed is like very productive. And so for a while there was like no way past this problem. It was like it was like scientifically or theoretically interesting, but it wasn't practically or economically useful. Until finally somebody had what in retrospect seems like a really simple idea. What if we cross the crosses?
Sure.
So he made a double cross. So you start with 4 inbred strains. You cross A and B, and you get an AB cross. You cross C and D, and you get a CD cross. And then you cross those two.
Then
and
AB and CD cross.
Exactly. So it turns out when you do that, you once again get something that has like very high yields. But since the parents were also high yielding, now you have an economical process. And this just like revolutionized corn, seed production. And especially during the drought years, the Dust Bowl, the 1930s in the U.S., it turns out some of these hybrid strains were really outperforming in the drought. And so very quickly, most corn growing in America converted over to these hybrid corn.
What years was this? Like, what? Give me a time frame.
Yeah, so the initial experimentation was done in like the 1890s through early decades of the 1900s. And then I think the first double crosses were done in maybe around 1920, give or take a few years. And so then kind of the industry developed some in the 20s and into the 30s. And by the 40s, it was pretty much, I think it was pretty dominant.
Fascinating. Well, so where can folks learn more about Roots of Progress and what you're working on? I believe.
So the website is rootsofprogress.org. Lots of essays there about the history of technology and the philosophy of progress, and you can sign up for the mailing list to get emails about new ones. And I'm pretty active on Twitter. I'm on Twitter as Jason Crawford, so follow me there.
Cool. Is there any way that if folks want to support what you're doing, is there a way
absolutely.
to support, or is that not something that you publicize?
Yeah, so we just launched as a new nonprofit organization, and on the website rootsofprogress.org you can find ways to support. We take Patreon monthly Patreon donations, or you can make a one-time through PayPal or other methods. So all the info's right there.
Awesome. Well, thanks so much, Jason. It's fascinating, and I think the work that you do is very compelling, and I'm just fascinated by it. I think it's super, super interesting. So even selfishly, I think it's really cool. But thanks for taking time out of your day to chat with us. Rootsofprogress.org, yeah?
Yep, that's it. Absolutely. This has been great. I agree with you. This stuff is super fascinating. And hey, this has been a fun chat. Thanks a lot for having me on.
Yeah, likewise.